All right, we're going to begin lesson 3, and then it always starts with a family letter, but it's a good introduction too for what we're getting into. So lesson 3, this week your student is learning about nets and finding the surface area of three-dimensional figures. Surface area is the combined area of all the faces or sides of a 3D figure. So we're working with three-dimensional. Okay, you've done volume, but this is talking about wrapping. So think of wrapping an item, that's the three-dimensional aspect we're talking about. Okay, imagine cutting a three-dimensional figure along some of its edges and unfolding it. So think of a box, laying it flat, not folding it together flat, like smashing it, but cutting all the pieces out, like they have right here in the middle, and you have to find the area of each piece. This is called a net first. Okay, you can also do it through an expression, which we're going to work through. That's our goal. Okay, there's an activity here that if you have time, you can always do with your family. Okay, so we're going to start here with our first problem. So read with me, and then we can get to make sure you have a full understanding of what you're going to do. Previously, you learned about the area of two-dimensional figures. So we've done triangles and parallelograms. In this lesson, you will learn about the surface area of three-dimensional figures. So we're moving from flat figures to three-dimensional. Brian learned to build a cajon drum, I think is what it is, from his grandfather. A cajon or Cajun drum is a box-shaped drum that you can play by slapping the front. Brian builds it as shown. How much wood will Brian need to build the 4 vertical sides, but not the top or bottom? So we're doing 4 sides, but not the top or bottom. Take a second, see if you can solve it. Pause the video while you work, and then come back and check your work. Okay. When I first saw this problem, you automatically want to do volume because that's what you know. You know that you multiply the 18 times the 12 times the 11 to get volume, but that's not what we're doing here. We're working with the area of the outside. So what I did when I solved this problem, I started, remember, excuse my drawings, I started by drawing my 4 pieces. Okay, this is my front, my back, my top, and my bottom piece. Okay, so my 4 pieces. Oh, excuse me here. I made the same mistake that I told you not to make. I'm going to erase this. This should not be my bottom. It says not the top or bottom. Okay, this is actually my left side and my right side. I'm glad I reread the problem again and caught that mistake. Okay, so my front, my back, my left, and my right. Well, the front is showing is this wood panel here. It's a drum you play by slapping the front. So this is my front. These are my sides. They're identical. My front is 18 by 12. To find the area, we do base times height. It's still the same thing. So this front is going to be 18 times 12. Okay, so 18 times 12. When you type that in a calculator, 216, and it is inches squared because it's inches here. My front and my back are the same, so my back is going to be 216 inches squared. My left now is 11 by 18, so 11 times 18, which after you multiply will give me 198 inches squared. And my right side is going to be the same, 198 inches squared. So to build these 4 sides, I need to add all 4 of those numbers together. I need to add 216, 216, 198, and 198 together. Okay, so when you add all these numbers up, you can estimate your answer should be about 246, around 800. When you actually add them up, you're going to get 828 inches squared, your surface area. Now you might be questioning, why is it squared and not cubed? Well, we didn't ever multiply 3 dimensions together. We never multiplied more than 2 dimensions together. Okay, so the next, actually taking all this information and actually using it or writing it out to make sense. So looking back, how much wood will Brian need to build the 4 vertical sides of the Cajun drum? How can you find the amount he needs? Well, we showed it on the previous page, but the actual answer here we already had is 828 inches squared. So looking ahead, what we're working towards. Brian's Cajun is called a right rectangular prism. It's a lot of words there, but prism has two bases. So when you hear the word prism, I want you to think of having two bases. And just a heads up, a pyramid, think of what a pyramid looks like, has one base. And here would be an example of a pyramid, and here's a prism. Two bases, one base. So a right rectangular means the faces are rectangular in design, and a right rectangulars have right angles. If you cut along some of the edges of a right rectangular prism, you can unfold the prism into a net. This is our net. This is our flat shape. We could fold this back together to make our box. How do sizes and shapes of the rectangles in the net compare to the faces or sides of the right rectangular prism? Explain. Well, they better be the same, because nowhere in here did we ever cut. We just flattened. Okay, so they are the same. Explain how you know. Well, we never made any cuts. We never added to, we never subtracted from. Okay, they're the same. It's being unfolded, but it's not changing the actual shape. It's changing the appearance of that. Question B, where in the net do you see the edges of the right rectangular prism? Okay, you see the edges. The edges are these lines that separate here. Where do you see those edges at? They are the sides of the rectangle. Okay. They are the sides of the rectangles. Okay, so make sure you're copying this down. Okay, for independent practice, you're going to start with question number 3. Go ahead and pause it, solve number 3, and then come back and check your work. Okay, how many triangles and how many rectangles are in a net for a right triangular prism? How do you know? So if you look up here, you can make nets for other three-dimensional figures. Look at the prism and the pyramid. How are they alike and how are they different? Well, solving C first obviously will help you solve 3. Okay, how are they the same? Well, they're the same because they both have 5 faces. Think of your faces as your sides. So this front is a face, the side here is a face here, the base and the top. Those are your faces. Okay, so 1, 2, 3, your 2 bases make it 5. Here you have 4 triangular pieces coming up and your base, they both have 5. Okay, the difference though is that base. A pyramid has 1 base, a prism has 2 bases. Okay. So how many triangles and how many rectangles are in a net for a right triangular prism? So we're working with the prism here for question number 3. Okay. A right triangular prism has, the bases are 2 triangles. Okay. And the faces are 3 rectangles. Okay. For your independent practice, you only have 3 problems. You're going to turn over to page 5. You're going to do problems 1 through 3. So problem 1, 2, and 3 on the next page. That's what you're working on independent practice for tonight.